Okay, so let's definitely pay attention here. I'm going to show you a super rapid way that we can smash out these chain rule ones. So previously we've been doing maybe 3 or 4 lines of working. We're going to solve these problems in one line of working. Because in a test situation, in an exam situation, this kind of question is worth 1 mark. So we want to make sure we're doing it the fast way and we can see the derivative. Okay, so let's get straight into it, and then I might talk about our substitutions and so forth. So we have some function to the power of n. That's what all problems involving chain rules are. There's some function to the power of n. If this is the case, then the derivative can be expressed as n f of x to the n take 1, that's the power rule, but then multiplied by the derivative of the inside function. Okay? So let's compare this statement with this one and see if we can follow this rule. Alright, f of x is everything inside the brackets, so our n is 5. Okay, let's follow it. 5 times f of x to the power of 4. Let's write that out. dy on dx will be 5 times f of x to the power of 4. Okay, that's the first part, that's this part, done. Then, multiplied by f dash of x, alright? Like people are furiously scribbling down. N, f of x, n take 1, multiplied by the derivative of this function, the one on the inside. So we just go through, differentiate term by term. What's the derivative of 3x? 3. What's the derivative of 4? 0. What's the derivative of 2x squared? 4x. Done. Full marks, okay? One step. We went from there to there, just following this rule. Alright? So just follow it along. N, f of x, n take 1 times f dash of x. Okay, so that's the fast way. The other thing I wanted to talk about is some of the substitutions we're performing. So if we have a look at this question here, you know, in this question in the test last year, it's a first principles question. It says, use first principles, find the derivative. Okay, you go through, you do it. And then it says, hence find f of 0 and f dash of 0. I mean, come on, geez. You put the number 0 into the function and the derivative function, and we're stating its significance. Okay, so that's a really easy one to calculate. When you put x is 0 in, what does it evaluate to? All right, we'll scroll down. There's another example I'll show you. So here, all right. No, that's not it. Here. Find the slope when x is minus 2. All right, that means the same thing as the way the textbook's saying it. They're saying it in a really elongated fashion, aren't they? They're saying, find the slope of the tangent at the point when x is 2. All right, all that means is, what's the slope when the value of x is minus 2? So you take the value of x is minus 2 and you're putting it into the derivative function. Okay, so that's probably as complex as it's going to get. That's as complex as the calculation is going to get that you have to do. Anytime that it's involving square roots or cubed roots, it's always going to be 1. All right, square root of 1 is 1. Cubed root of 1 is 1. All right, or 0. 1 or 0. So, yeah, any questions about the substitution? All right, so some of the ones in the textbook can be quite tricky, but nonetheless, it's a good opportunity to practice our number skills. Okay, so that's all from me today. Just keep hacking away at this exercise. There are some tricky ones towards the end. I encourage you to have a go at them, but definitely we will review them come our next lesson.